Hello Year 10, right, or good afternoon should I say. This is our second lesson on probability, and we're going to go through exactly the same kind of model that we did yesterday. So start off with the 20 questions, and then we will move on to the answers and today's lesson. So if you make a start with those 20 questions, the answers will follow on the next slide. So you will need to pause the video to have a go at those. Okay, answers. So there are all the answers. Managed to get them on the screen today, which is a bit more helpful. If there are any on there that you're not sure about or don't understand where the answers have come from, please make sure you put it in the chat on Show My Homework, and I will pick that up on our lesson on Thursday. Okay, so what we are going on to today is estimating a probability. Now, yesterday's lesson, we were talking about theoretical. So like if you roll a dice, the probability of getting a 1 is 1/6. If you flip a coin, the probability is a half. They are theoretical probabilities. So to get estimating probabilities, what we actually do is we look at the number of events that have happened. So let's have a look at a couple of questions and we'll talk through these. So we've got a spinner. Spinner has A, B, C on it, so let's just A, B, C. Okay, I spin the spinner 50 times and I see A 12 times. What is the experimental probability? Well, you can use the information you've got here. It's also called the relative frequency, because when you do it 50 times, it comes up 12 times. So actually, the probability of getting an A is 12 out of 50. You can leave it as a fraction or you can put it as a decimal. Okay, it's called the relative frequency. It's happened 50 times. We've got 12 of them, so 12 out of 50. Now, second example we've got here. The probability of getting a 6 on an unfair die. So in other words, it's unfair. So it's not an equal amount to land on each number. So we've got a probability of 0.3, but you're going to throw it 200 times. How many 6s might you expect to get? Well, there is going to be a calculation involved, so just have a little think about what you would do to work out how many times you would get a 6. Well, if you decided that you would do 0.3 times 200, you would be absolutely correct. So you would expect, and it is only expectation, remember it's estimating, it's from experiments rather than theoretical, so you'd expect to get a 6 60 times. You've basically done 200 times 0.3. Okay, so there's a couple of examples. Now let's have a little look at this. So the Royal Mint, who makes British coins, claims that the probability of throwing a head is 0.4. Okay, so they're not 50-50. Mr. Brewster throws a coin 200 times and sees 83 heads. He claims that the manufacturer is wrong. Do you agree, and why? Okay, so there's a couple of ways we could look at this, but if we are doing it 200 times and the Royal Mint thinks the probability is 0.4, what we could do, 200 times 0.4, well, 200 times 0.4, you would expect to get 80 heads. Well, I got 83 when I did it. If we actually follow, the probability is 80. So I would say actually that I'm wrong, because 80 and 83, very close. Bear in mind we're doing experimental probability, so it's not going to be exactly the same every time. It's all to do with how many chances you get when you flip the coin. Okay, so again, we're doing this 200 times 0.4. Okay, and if we uncover the grey box, it will explain that. If I press the right thing, there we go. So it's likely the manufacturer is correct. Okay. So a couple for you to test yourself with. So I'm going to leave them on the screen. I want you to have a little read of them, have a go at them, and then I will talk through the different answers. So pause the video, have a read, see how you get on. Okay, so hopefully you've paused the video. Very, very common type of exam question, these. So the table below shows the probabilities of a spinning an A, B and a C on a spinner. Okay, if I spin the spinner 150 times, estimate the number of C's I will see. Well, we actually haven't got the probability of C, but we know that our three probabilities, remember, they always add up to 1. So what we can do, if we do 1, take away 0.12 and 0.34, you actually get, I'm going to do that on a calculator, sorry I should do that in my head, but it is late, so there we go. So the probability is 0.54, and that's the type of exam question they expect you to fill in a little table of values like that, but you know they all add up to 1. Now, if we do it 150 times, so our calculation is basically going to be 150 times 0.54. So actually we're going to get 81. So hopefully you got that one correct. Now, question B, this time we've got to spin another spin 120 times and see the following count. So we've got 30 A's. Okay, what is the relative frequency of B? Well, the relative frequency of B is going to be 45 out of 120. So 45 out of 120, you could have simplified, you could have kept it as a fraction, or you can put it as a decimal. 45 divided by 120. So it's 0.375. Okay, so 2 different questions just to check your understanding. Now, if you are happy with that and confident, what you can do, you can go on to the exercise 6. I've attached the sheet on Show My Homework. Have a go at them. There are 8 questions. Okay, and once you've done the 8 questions, you can come back, unpause the film, and I will reveal the answers. Okay, so have a read through, do the questions, and see how you get on. Okay, so hopefully you have now done this sheet and my examples helped you. So I'm just going to uncover the answers and obviously mark your work and correct it. So question 1, we've got an unfair die is rolled 80 times, and these are all the different amounts it's come up. So relative frequency is going to be 20 over 80, except they've put it as a decimal, but you could have 10 over 80, 8 over 80, etc. Okay, so you could have left them as fractions. Now, Dr. Bob claims that the theoretical probability of rolling a 3 is 0.095. Is Dr. Bob correct? Well, the theoretical probability is basically going to be, well, he's correct. He's close, isn't he? Because he's 0.1 as opposed to 0.05. Okay, so actually they're quite close. And that's really what you're trying to get to. Okay, question 2. So we need the probability of getting a tail. Well, it's either going to be heads or tails, so you take it away from 1 and then you do your multiplying by 75. This time we've got a fair die is thrown 600 times and we see 91. So what's the relative frequency? Well, it's 90 over 600. How can she make it closer to a 6th? Well, the more you do it, so the more throws she does, the more accurate it gets. So, if she did it 6,000 times, her probability would get closer to 1/6. Okay, so now we've got a table. We've got x and 2x. So to get these, what you needed to do, the table below shows the probability of winning a different prize in the game show. estimate how many cuddly toys. So we need to work out the value of x, but we know they all add up to 1. So if we do 1, take away 0.37, take away 0.18, which gives us 1 minus 0.37 minus 0.18, gives us 0.45. But because that's 1x and that's 2x, we need to divide that by 3. So actually that is 0.15 because it's 1x, and this one is 0.3 because it's 2x. And then we want to know how many cuddly toys, so it's going to be 0.15 times 160. So 24 cuddly toys. Hopefully we're getting these correct. Okay, next set of answers. Okay, we've got a 6-sided unfair die is thrown n times the relative frequency given. What's the minimum value of n? Okay, well they're all multiples of 0.04 or 1 over 25. It's quite a tricky question, that one. So there must have been 24 times, a minimum of 24. Okay, a spinner with sectors A, B and C 200 times, and that's quite good English. I see twice as many B's as A's and 40 more C's than A's. Calculate the relative frequency of spinning a C. So what you really need to do is you need to form the equation. Okay, very common question. So A is X, B, because it's twice as many B's, so you've got 2X, because you need twice as many, and as A's, and 40 more C's than A's. So in other words, A plus 40. So you've got your values. You can form an equation because we know they're spun 200 times. So we can add all this together. We've got our equation. We can solve it. So to solve it, I'm sure you guys can do this. 40 equals 200. So take away the 40. And then divide by 4. So x is 40, and once you know x is 40, you can work out the relative frequency because it's going to be 40 plus 40, so 80 over 200. Okay, question 7 is your answer there. Relative frequency, a fair coin some number of times, and the relative frequency of heads is 0.45. And you'd expect the relative frequency to be a half. Okay, so actually you're throwing it a couple more times, get one more head. Okay, so the minimum number of throws is 22, and then these last ones are quite tricky. But I would say up to this stage you're likely to get onto your GCSE exam paper. These are probably more of your extension challenge questions. Okay, so that's your worksheet for today. Now, yesterday some of you were really helpful in the chat. You put your learning review, which was really good to see. Really helped me plan what we were going to do today. So if you could please do the same, and then I will be able to plan Thursday's lesson for you. Okay, thank you.